Now that we've discussed how to write your procedures, we need to go ahead and start setting up data tables to where you can begin your experiment. Now, the first thing we need to recognize is what is raw data. Raw data is actually data that you directly measure in a lab. You go and you use a tool, an instrument, and you get that measurement. So we need to differentiate now between direct measurements and indirect measurements. A direct measurement is any measurement taken using a piece of equipment in the lab. You actually see it with your eyes and then you write it down. These would be things like displacement or time or mass, maybe volume or heart rate. There you're not using your eyes necessarily as much as you're feeling the heart rate and using a stopwatch. Those are direct measurements. These are things you can record immediately. Indirect measurements are ones that you need to calculate from direct measurements. So you get these things, or a few of them, and then you combine them. Things like velocity, displacement divided by time, acceleration, maybe you need to use one of our physics kinematics, molarity, moles per liter, density, some unit of mass divided by some unit of volume, percent change in mass, you need two masses, and then you're actually going to run through a percentage for biology. Now, there are three types of data tables that you're going to end up putting data in. Raw data tables are the first thing that you're going to end up doing. You're going to go to the lab and you're going to collect what's raw data. Those are all direct measurements. Then, if your question involves one of these indirect measurements, you're going to need to do some calculations. Let's say your question was about speed somehow or another, or velocity. Well, you're going to need to raw data, collect displacement and time, and then you're going to need a calculations table to where you actually calculate the velocity. Finally, you're going to have a graphing table. A graphing table is where you strip away all the other stuff that you've done and you isolate all the way down to the independent variable in one column and the dependent variable in the next column. Thus, it's set up nice and easy for your graph. Let's now look at how to set up your raw data tables. Over here, we have the procedures that you saw from one of the previous videos. Question, how does the height a ball is dropped from affect the time it takes to fall? Notice in our data table, our raw data table, all of the heights that we picked for our independent variable are already set up here for our independent variables because we must do 5 trials. So here are 5 trials. And we have to have 5 repetitions at minimum. So there are 5 spots where we're going to do it over again, times 1 through 5. We're going to drop it, and then we average all of those repetitions there after we've done all of our tests. You also need to make sure that you include units for everything, and uncertainty, plus or minus. Check out the error and uncertainty video if you have questions about how to figure that out. It's also easiest to go ahead and absorb both the units and the uncertainty up into the headers up here, so you don't have to rewrite it on every single one. So if this entire column is going to have the same unit, which it will, it's time, so seconds, I'm going to absorb my seconds up into the header. Also, since this is a direct measurement, my uncertainty coming from the stopwatch, all of these are going to have the same uncertainty too, so I can absorb that up there. Where here in the average times, while the unit remains the same, the uncertainties might be different, so I wouldn't absorb that into the header. Also, make sure to go ahead and give it a title or a label. That way you actually, and a reader actually knows what this data table is supposed to be showing. Finally, make sure that your procedures and your raw data table actually match. In fact, you should be able to set up all your data tables long before you come into class or go anywhere to actually do your experiment. After you do your procedures, go ahead and create the data table that then you are going to fill in. Let's do another example that involves collecting raw data. How does the height a marble is released from on a ramp, similar to this, affect the time it takes to travel 1 meter down here at the bottom? Now, this question is all about direct measurements. Height is a direct measurement that I can use a meter stick for, and time is a direct measurement also. Time it takes to travel there, I just simply use a stopwatch. So I'm going to collect some raw data, and then I'm going to average my times, and that'll allow me to actually get to my graphing table over here, where my independent variable, drop height, is the first column, and my dependent variable, average time, is the second one. Now, it's not a problem for me to go ahead and get these data tables set up because I would have had all this written down in my procedures. I already had chosen the heights that I was going to drop things from, and so these would be set up even before I came and collected data in a lab. So let's go ahead, let's collect some data really fast. Now, of course, after you've done this for a little while, like I have, you learn how to move at teacher speed when trying to collect data, as you can see here. So now I have all my data in my raw data table, so I just need to average it. Now after averaging, I noticed something odd here. At 0.3 meters and 0.4 meters, the two times are relatively the same. So looking at my 0.4, I see an outlier here. This doesn't make any sense. I'm going to go ahead and circle that. I would discuss why it's an outlier in my lab report, because quite obviously I have 4 times that line up quite nicely and then one that sticks out like a very bad sore thumb. So I'm going to circle him and exclude him from my average. Now I've got all of my averages done and corrected here. This is much better whenever I get rid of that outlier. I went ahead and calculated my uncertainties. Now each uncertainty is different because the uncertainty due to the averaging, due to the spread, the range in my data was actually greater than that of the actual stopwatch itself. So everything got its own uncertainty. Now I'm ready to actually take this and put it into my graphing table. The graphing table is just simply there to make it where we isolate the independent and the dependent variable. So as you can see, I've got my independent variables that I need to copy over down here, and my dependent variables that I need to copy down here. And after copying those over in the graphing table, the entire point is just to make it look simpler, to where we recognize it's very easy what to graph. Here, this would be my x, right, the independent variable. Here would be my y, the dependent variable. So it would be very simple to plot my points with x and y for each individual point. In the next video, we're actually going to look at what happens if you need some indirect measurements. You're going to end up using a calculations table, and then of course, video after that, how to graph these.